Yeah, so today we plan to cover in this info session, what is iGEM? What are the results of iGEM for both students and mentors? So as mentors, you have an idea of what that might look like. Logistics in the iGEM cycle, what a mentor does, and some key dates to keep in mind, including deadlines for like a very, very short application. And the remainder of the hour will be some prior mentors answering any questions that you might have. And the hour after this info session, we plan to have an info session for students. So you're welcome to also see what the student process is like and get a sense of that as a mentor or interested mentor. And this is the webpage that we have all the information about both mentors and students who are interested in iGEM on that page. And again, this session is being recorded. Cool. So what is iGEM? iGEM stands for the International Genetically Engineered Machines Competition. And this has been a competition that has been started at MIT, and it's for teams worldwide to ideate projects, design experiments, analyze the results, and communicate their work. It's very much a team-based environment where a lot of undergrads, and specifically MIT undergrads, but then we've also welcomed high school students as well as master's students to attack hard problems. And it's very much in the kind of mindset of a mentored academic startup almost type of atmosphere. Finally, it's also a place where ethics, policy, and science meld together to inform science and society positively. So a core component of iGEM is also thinking about the ways in which you communicate the science, but also assess the impact of the project on the wider world. And so we'll talk a little bit about that as well. So what is iGEM? We consider it like this vibrant, collaborative community furthering synthetic biology. And so this was an image from iGEM 2015, and you can see there's a lot of people from all over the world, several different teams, all with different colored shirts. And it was the MIT iGEM team in particular has been at the Synthetic Biology Center at MIT for a long time now. But this year we hope to move it into the Huang Hobbs Biomaker Space, which is at the bottom of Building 26, and some of you might have passed by it. And really focusing on all of these different questions is kind of the purpose of iGEM. And we're hoping that with this new space, we'll specifically be able to empower students to be able to start their own independent projects, but then also be able to creatively think and test them, even if it's just for fun. So here are some of the iGEM values that you may or may not know and want to keep in mind. And I think the quote that has always stood out to me as a past iGEMer has always been that iGEM is really difficult, but we make it worth the effort. So a lot of students find that after the entire process, they really found that they've grown a lot. They've learned about the whole entire research process, and also thought about like, how does their project actually look like in the context of society and the larger world. So in particular, human practices has been a very large component of iGEM that was introduced like towards the early years of iGEM. And really it's about thinking about how your project impacts the world and how the world affects your work and your research and project. And so these are some previous teams and what they ended up doing with their projects. Besides their core actual technical research, they often have gone on to like develop dictionaries, for example, to translate a lot of scientific jargon. They've made more accessible wikis. So in particular, I remember one team doing some work specifically looking at how to address people who might have difficulty seeing specific things on websites, so like people who are colorblind in particular. A lot of people will also delve into the bioethics side of things and biosecurity. And so an iGEM alum has gone on to present and represent iGEM at the UN bioweapons conference before. So that's also pretty cool. And a number of teams have also looked at patents, for example, and what it's like to bring their project and turn it into a business. And so MIT teams have also been able to hold an educational workshop at the MIT Museum. And obviously that might not be possible if things are virtual, but they've also interviewed professors, researchers, physicians, patients, activists, people who have a stake in their project and research and work. So iGEM is particularly known for the registry, but I won't go too much into it because, to be honest, it's a bit out of date and I think does need to be updated. But it basically has all of the standardized parts that teams have collected over the years and built so that it's open access and meant to be used for everyone. And a number of labs have used the iGEM registry and the parts from there to create a number of their own research projects or do their own work as well. And so what is iGEM in terms of its history with MIT? So iGEM was created actually at MIT through an IAP class in 2003. And the competition was actually held at MIT until like early 2010 or so. Deepak might be able to give me the exact year for that, before becoming an international competition and nonprofit organization. And all the founders were at MIT at one point. So Randy Ritberg, Tom Knight, and Drew Endy. And the MIT team has had a team nearly every year since 2003, even this past year in 2020 when everything was all virtual. And we have to give special thanks to Professor Weiss and Deepak Mishra for that, and the Synthetic Biology Center. And so members of the 2005 to 2006 MIT iGEM team are known to have also founded Ginkgo Bioworks, which you may or may not have heard about, in Kendall Square and in the kind of Boston biotech community. So as iGEM has grown from this kind of early community to this very large stadium of people now, I think in 2019 they actually had to do a video because there was too many people. There have also been new tracks kind of introduced where people end up looking not only in the kind of health arena, which a lot of biotech is currently focused in, but all these other kind of areas of interest and ways in which students can kind of conduct research. And they're hoping in future years to actually fit these to the UN Sustainable Development Goals so that iGEM as a whole better kind of progresses and tries to fit the needs of what the world sees as big challenges in the coming years.
So one of iGEM's big strengths is how interdisciplinary the projects can be and how there can be space for people from all sorts of different backgrounds. So as Melody talked about a little bit, there's a wide variety of different projects beyond just healthcare. And this leaves a lot of room for possible projects and creativity in the realm of synthetic biology. So some examples in the past have been 3D printed tissues, which focuses on the manufacturing the environment, such as bacteria that kills bee mites. And within these projects, there's a little bit of room for pretty much everybody here, from people who have a stronger background in art to people who have backgrounds in molecular biology. So to go a little bit more in depth, this one is a foundational advanced one, which built all these different parts, which create these different fluorescents. So there's this pretty cool video about them that we can watch a little bit later if there's time, or if there's not, you can check it out yourself. We'll send it in the chat. Here's one that focuses on human health. In 2008, the winner was Slovenia, which prepared a vaccine against Helicobacter pylori, which creates stomach ulcers. Some examples from MIT include tissue by design. So this was a pretty cool project, which looked at tissue self-construction to achieve specific patterns of cell differentiation. And this was pretty neat because it involved both software simulations for people more interested in computational biology and lab work for people more interested in bench work. And the entire team learned how to apply their skills to one common theme. It's also communication, logic processing, and cell adhesion. So another cool thing about iGEM is that the project doesn't necessarily need to end in a single season. For example, the 2011 winner, University of Washington, ended up creating this startup called TVP Biologics. Another example from MIT, again in the manufacturing track, focuses a little bit more on material science by creating these self-adapting, self-repairing living biomaterials. So basically, how that worked is that it took in UV and mechanical signals, processed this using a bacteria toggle and mammalian switch, and could respond by forming modified phages or bones. Yeah, and this is just a visualization of what that project looked like by taking in this input, processing it, and then having a specific programmed output. So for our year, we focused on computational modeling since we were all remote. But what we did is that we created a system that could simulate a cytokine storm caused by COVID-19. And what this model did is that it allowed us to simulate drug targets by testing out what would happen if we lowered the concentration of different cytokines. And as you can see, there's from like all of this, there's a pretty large variety of possible projects for the 2021 team, depending on the team's interest.
Okay, so results of iGEM on the mentor side. So mentors get to have an entire trustworthy pool of undergrads who are always ready to help out with research as lab-trained UROPs throughout the iGEM team. And then mentors also get the opportunity to hear and see diverse projects going on globally by exploring various projects by teams across the world. And besides obviously being awesome people, mentors often go on to become awesome professors and researchers, which is really cool. iGEM also gives a potential opportunity to go to Paris and judge at the iGEM Jamboree in 2021, although this would happen only if the COVID situation improves. And then you would also get to be a part of the proud MIT iGEM history. And then, oh, yeah, just to like go over the iGEM cycle really quickly. I guess like each year the cycle begins when our team is formed, and then that's when we also begin fundraising. The team also starts brainstorming project ideas, which is when the mentors also guide and advise. And then the team determines like tasks and goals. And then starting the summer, the team starts wet lab, although this like depends on the project, run functional experiments, process and plot results, and then work on organizing all their info for the project on the team wiki and registry pages. And then starting the fall term, the team finishes final experiments, finish the wiki poster and presentation, and then in November attend the Giant Jamboree. So the Giant Jamboree is an in-person attendance of all 300 more teams participating in Boston, Massachusetts. And then the plan for 2021 is in Paris, France. So that is very exciting. There are 14 tracks in the competition because synthetic biology can be applied to nearly all industries. So there are a variety of choices that the team can make. There are people from all over the world who are trying to solve different problems, and then they're meeting in the same place, but speaking the same language, synthetic biology.
And then this is just a sort of general timeline that we anticipate for the coming year. Of course, it's going to be pretty tentative, especially since we're not yet sure what the summer is going to look like. So in the spring, that's going to be the first brainstorming phase, which can occur virtually. And that's going to involve meetings between the team members and the mentors about 1 to 2 times per week. And generally, mentors will be present for most of these meetings so they can help answer any questions the team has, as well as help bounce ideas off of. And then in the spring, later during the term, conditions permitting, we may be thinking about hosting a bootcamp for the team so that they can get a head start on learning any necessary skills that they might need to execute their projects in the summer. So the general time commitment for the spring for mentors is going to be looking about 1 to 2 hours per week. And then this summer, that's when most of the project actually gets done. And again, hopefully this will be in person, but there's also a possibility that it's going to be virtual depending on conditions. And in the case that it is virtual, it's not going to be as high of a time commitment, but it's still important for mentors to be present to answer any questions that the team might have as they come up during the experiment process. So this is going to be a bit higher than the spring. It's going to look at closer to 3 to 4 hours per week. And then finally in the fall, at this point, most of the project should be done. And the team's going to be focused on creating a presentation and a public website to present at the Jamboree, as well as to share their project just to the public. And so this is going to be closer to the sort of time commitment in the spring, where mentors aren't needed as much for live support with the projects, but with just working with sort of developing posters and presentations. So what is a mentor going to be doing? So as we said before, mentors are going to be helping the team throughout the entire research project, from developing their ideas to presenting it. And the exact roles are going to vary a little bit depending on the stage. And so again, in the spring, this is going to look at communicating and meeting with the team, as well as with individual members to discuss what projects they might be interested in, as well as thinking about what sort of projects might be more feasible, since not all members of the team might have the same amount of experience with developing experiments. And also during this stage, this is also a good time for mentors to also learn with the team, because not only is the team going to be concerned only with experiments, but they're also going to be considering all aspects of the project, including how it relates to society and to the current state of the research. In addition, once the summer rolls around, the mentors are going to be focused on helping out with the actual contents of the project, especially with sort of experimental techniques that the team might need help in learning, and also being a source of motivation and support for the team, since this can often be a very difficult period to work on the project. And finally, mentors are also going to be giving suggestions that they might see along the way, and that applies to any state of the project, and also encouraging the team to find new solutions for themselves as well. And finally, these are some of the key dates that are coming up in the next month for the actual application process. So on February 5th, the application is going to be due for the mentor team. And this consists of only 3 short questions, which is about a total of 250 words. And you can see more details of the exact questions on the website. And then for actually submitting the application, it will just be emailed to this address that you see on the slide. And then within the next 2 days, the mentor team will be selected and finalized by about February 7th. So we don't anticipate to be a very long process. We mainly just want to see why you want to be a mentor, what sort of time you have, and what sort of resources you're able to provide. And then on February 10th, which is a few days later, the application for the student team is going to be due. And this application is much longer because we want to see more of why the students want to participate in this. And this application can also be seen on the website. And then the student team is actually going to be selected by the mentor team, hopefully within about 2 or 3 days. And then the mentor team will notify us of their selections. And so after this team is selected, we do hope that this happens before students arrive on campus, because that's going to be a more busy time. And then after the quarantine period, about the week of February 21st, we aim to have our first meeting with the entire team and all of the mentors.
And that will be a virtual meeting, just to be clear. But yeah, so we did have a panel kind of sort of prepared. We have some past mentors who were both grad students and postdocs and now professors. And then I have also been like an undergrad mentor, less technically experienced, but have experienced the team experience before. So you're welcome to ask any questions from here on out. Thank you. Cool. Yeah, I think that's about it though. You can apply here if you're interested. And we're having the applications open for the next week. And if you have any questions, you're welcome to email us as well. And then I'll just leave it on this slide so we can answer questions. I guess if not, I will just go ahead and ask the previous mentors questions then. What was your like most memorable experience or most, I guess, best takeaway that you can give to future mentors on the of the iGEM team? And I'll just pass it off to Jan then.
Hi, so maybe I should introduce myself first. I'm Jan. I was a mentor of iGEM teams in Slovenia, participating in the 2008 as a student. That was the immunobreak that you mentioned. And then I was mentor in 2012, 2016, and then also at MIT in 2019. I really like that when you said like on your slide, what a mentor should expect was learn with the team. I think that was one of my best experiences because iGEM, both in Slovenia and at MIT, has always been introducing new projects to the lab and learning both like theory and experimental techniques and the application of it for both the students and the mentors. And I think there were a lot of great projects that came out of it and really enhanced my CV as well. And then just generally working with a team has been very satisfying. Usually the students are like super motivated. And even after the iGEM competition itself has been concluded, we have continued to collaborate with the same students and mentors to finish the project, publish a paper, or as you have mentioned, some teams go on to found companies. So definitely also take advantage of meeting the new people and collaborating.
I have a question. Can you talk a little bit about the biomaker space and like what you have there? Like what sort of things you can do, what equipment you have?
Yeah, so I'll just exit this one and real quickly pull up the site. Yeah, so the biomaker space, bottom of 26, this is how you can like kind of see what the space kind of has. This equipment list has to be updated. So we have all the kind of standard stuff in BL2 kind of space. There is a tissue culture room as well. And we're hoping to actually get a bioprinter from an alum who is specifically interested in some of the projects going on in the space. But we have like some of the basic equipment that you might typically have. A lot of this is, I think, somewhat secondhand. I think Justin is in this Zoom call as well and probably can elaborate on exactly what we have. But we're like really grateful because a number of the equipment that we have gotten has been from professors, but we have also gotten a lot of new equipment also thanks to the help of a lot of sponsors. So if Justin is in here, please feel free to add.
Yeah, I'm happy to jump in as well. Yeah, as Melody said, we have most of the basic equipment right now. We had just been booting up the new space, which I mentioned is in the basement of building 26. The construction on that finished in November of 2019, and we had really that basic equipment in place by January for IAP, and we were getting ready to run everything, and then start to shut down for pandemic. So we still haven't equipped with perhaps some of the bigger items that we may eventually have in the future, or more analytical items. So hang on just a second here, I'm multitasking, unfortunately. Yeah, so BL2 for the whole space, TC room with 2 biosafety cabinets. It's separated from the general lab space. The general lab space has a biosafety cabinet as well, so you can work with opportunistically pathogenic organisms there. We have anaerobic glove box, which was a gifted item. We have larger refrigerated centrifuges, small microfuges, donated UV vis spec. We have a 5-mode plate reader. We have a bioreactor. We have FPLC, which was donated. We have 2 fluorescent scopes, which were donated but not in use. We have a force robot. A lot of fun toys, and a lot of which you'll keep hearing me say haven't been finished setting up, haven't been retested out. So we got a ways to be fully functional, but that's kind of the gist of it. The idea is that it's a resource that's available for anybody in the community to use. We've got a plan which is approved for reopening, so we'll be good to do reopening in March. We'll have a very limited capacity for spring, obviously because of COVID and access requirements. And also, we don't have any confirmation of summer. That was included very explicitly with the spring approval, was we'll have to re-review for what summer means. So as far as iGEM is concerned, we'll still have to keep waiting to find out. That'll happen later in the semester. yeah, other features or any questions specifically on what I didn't cover?
What would be the person limit if it were to reopen?
Yeah, so we can do about 6 simultaneous, and we're trying to get a better number on what we can support team wise, because that would be instantaneous. We're gonna have a reservation system so that people reserve a bench for like 3-hour time increments. And we want to make sure that the teams that are working in there have enough access, because obviously if you can't get a time slot, that's very problematic for biological lab work. So we want to make sure that we're not oversubscribed. We would have said previously, before there were any restrictions, we could support 40 teams working in the space. I think we're going to be well below half of that. We'll have to see as we get descriptions of what's coming through. And
Can I just jump in with a, oh, sorry.
Oh, just the last thing I'll say, we've got the lab tour video, which I need to get finalized and posted. We'll get linked off the website too, so everybody can see the walking tour.
I was just going to jump in with a quick question. I'm curious to hear how the team goes about selecting just one project to work on, or is it the case that you work on multiple projects? Because it sounds like there's so many possible things you could do. There's so many different tracks in synthetic biology. How do you possibly decide on just like one single project to work on?
Yeah, so I can answer that one. So hi, I'm Deepak. I'm a postdoc and instructor in course 20 at MIT. And I've had the fortune of now mentoring 8 of the last 9 years of iGEM teams. I took a year off the year I had to defend. But the process, at least how we've done it when based out of just kind of the mentorship coming from Juan Weiss and the Synthetic Biology Center, is kind of twofold. One is we're always looking for a wide variety of students. So we are going to get electrical engineers, biologists, chemists. You have the composition of MIT is such that some years we're going to have many more domestic participants, some years we'll have more international. And then the mentorship team actually plays maybe the most primary role, which is over the last few years, MIT's done a lot more mammalian synbio projects because we had a lot more mammalian expertise on the mentor side. So the process that we've typically done has been pick our students, get our mentorship team, and as part of the student application, one of the first things they write is a prompt of, if you could design any project, what would you do? And then it's a combination of introducing synthetic biology topics, as many of them are often freshmen, and doing some successive voting system where everyone gets to propose 1 to 5 ideas. And then we start eliminating, okay, like only one person is interested in doing like mining tailing ponds remediation. And so if that goes up to a vote of 10 students, we drop off, say, 20% of the things. The next week now you have little pitch meetings where now each student pitches 1 or 2 ideas, and eventually get to the case where you'll have 3 parallel ideas, and that's going to be about the March, April, May timeframe, where then we actually start trying to get through is like, what does a project look like? Because so far we've only been looking at topics like, can we design circuits? Can we design systems? And this is where the mentorship team is so important, in that we can dope ideas in. So for instance, Professor Strano of chemical engineering reached out to us on the mentorship side being like, hey, like I'm faculty in chemi, I have some interesting ideas and expertise in chemiluminescence. So if the students end up going that route, like I want to be involved. Likewise, like if we end up in plant synbio, like Chris Voigt and others are also doing like plant-based synthetic biology. So they may be interested or mentors. But the hard thing is the spirit of MIT is very much student driven. So other teams may actually have a project idea given to them based on, if it is my lab and I'm giving money towards the students, like let's have them do something for the lab. And BU a few years ago is a great example of that, is they wanted to do robotic moclo. So they said, we're going to do robotic moclo with bacteria. And then in that framework, you can innovate. Last year, because of the pandemic, it was very much like we want to do something with COVID. So then it was a matter of finding out, okay, what aspect of it we will attack. But I think the spirit of iGEM, at least at MIT, is very much, we want the students to be invested, involved. And that only happens if they ideate themselves. That being said, if we take our mentorship team and all of us are mammalian synthetic biologists, we are probably going to end up encouraging them to tackle subjects that we can help, right? If they want to do something with fungi and none of us actually even know how to clone or have any of the laboratory skills to do so, that's probably going to be a tough time for the team to succeed as well as the mentorship benefit. But I think Melody can also talk a little bit, like in practice, it's a black magic kind of black science, which is as mentors, we will sit down together and be like, what are we interested in? What do we want to get out of this? How can we guide the students on a path that it looks like their idea, but it's definitely the art of making an idea feel like it's their own without it necessarily being conceived by themselves. And I think that's, as graduate students and postdocs, we know what that looks like very well when it comes to our committees and the graduate coordinators we work with. I will add that because we're in the biomaker space, in years past, it's always been coming out of the Weiss Lab, and that has been great in some ways, and it doesn't tap into, I think, the wider community always, because it is housed at the SVC and more siloed. By being in the biomaker space already, we're getting much more traction from all of the other majors. And if you notice, if you look at the equipment, there is a lot more opportunity for doing mechanical and electrical types of things alongside just like kind of hardcore synthetic biology, if you will, where coming from the synthetic biology center, it's always going to be like, how many promoters can we build versus can we solve problems with synthetic biology? And that's one of the things we're trying to do in making MIT iGEM more kind of like self-sufficient, self-sustaining, is we now have undergrads running the show versus faculty running the show. And I think that's going to be just really cool, is it means that I think the ideation process this year is going to change dramatically because of that. I think is one thing that I'll add is I've been working with like Justin and other instructors in BE. So right now, if you lived in like New York or Arizona or 10 other states, in-person college instructors would qualify for the vaccine. Massachusetts right now does not allow that. It looks like that's going to be changing in the next 6 weeks or so. So as an iGEM mentor, one added bonus could be you could get your vaccine earlier than the general public. So I'm just going to put that out there. We're still trying to figure out the specifics, but this is something we're actively looking through right now, and like a course 20 instructor role as a whole.
Yeah, I guess to add to that too. So in the past, I've talked with some other people from other teams. I've been kind of an ambassador for the iGEM Foundation before, and in particular, some, for example, Ginkgo Bioworks creative director, Dr. Christina Agapakis, specifically talked about how she mentored the Harvard iGEM team back in like 2008, I think it was, or later. I forgot exactly when. But she talked about how they used to receive TA credit. So I'm going to try and see. I don't know if we can do much, but we're going to try and see if we can potentially make it like a class in the future. Maybe not necessarily this year, but to see if we can get some other types of benefits for graduate students and other types of mentors. But yeah, if maybe we also talk to Misty France, we hope to also send people to Aristotle, I guess. But those are like hopeful options, I think, that we're willing to like look into exploring. But yeah, I'll let Shiva talk about her experience as well, because I invited all these other prior mentors to talk about their experience, since it might be different depending on the mentor.
Yeah, hi everyone. My name is Shiva. I was a mentor for the iGEM team in 2019. And I think my first exposure with iGEM was as a graduate student at Johns Hopkins. And before Jeff Boki leaves for New York, he was basically part of this effort to create this synthetic yeast genome. And I think his science paper that has like hundreds of names on it, like a lot of them are actually undergrad iGEM students who helped drive the project. So it actually had a lot of energy. That project had a lot of energy because of the iGEM students. So once I came to the Vice Lab, I was very interested to be part of this. And I have to say, I enjoyed it very much because also it was very unique and very different from my other mentoring experiences. As a PhD student, I had mentored master's students or undergrads. It was more on a one-on-one basis, but it was the first time that I was basically mentoring a team of students. And I think the questions and the challenges and the excitement is rather different from the one-on-one mentoring I mentioned. I learned a lot from students who are coming from different backgrounds, and also from the three postdocs that I worked with, Deepak, Jan, and Nika, who's not here today. So it was really great into getting into their basically thoughts on how they approach problems. So I definitely appreciated that. And also I think overall, as a postdoc or graduate students, the problem what we embark on are a little bit more pragmatic because we have to publish. But the iGEM projects could be a lot more exciting because there is not so much emphasis on publication. You can tackle really cool projects and get recognized for it. And I thought for that reason, it was quite also energizing to work with a team that was brainstorming on cooler projects that are rather a lot more ambitious. So that's it, actually. Thanks, Melody.
Yeah, thank you. I'll just go back to the slide, I guess, that had some of the example projects. Maybe if that's helpful. It's like this one. Yeah. And if there aren't any more questions in like the next 3 minutes or so, I think we can end it here, and you're welcome to email us with any more questions. Unless I don't know if Ben wants to also give a explanation of his experience as a grad student for last year's team while remote. Feel free to also ask. Yeah.
I can go real fast. So yeah, hi everyone, I'm Ben. I'm a first year BE student. And I was a mentor. I'd say I was a half mentor for the 2020 season because I joined about halfway through. But I was just starting my time here at MIT as a BE student, so I knew nothing about synthetic biology. So for me, it was actually a really good time to just learn alongside the students and then try to help them out wherever I could because I did have a decent bit of molecular biology background. So I'd just say overall, I was really impressed with the team and how driven they were to sort of figure out this problem in the middle of the pandemic, and just how driven they were and how little, it's kind of funny. Once you graduate, you think everyone who's just 1 year old younger than you is like a baby, but there's like no babysitting as a mentor. It's really just working alongside a really great team. But yeah, my experience was obviously a little weird being in the middle of the pandemic, but it was still a great time.
Cool. Yeah, so if there aren't any other questions, we probably will wrap it up in, I guess, the next minute or two. And again, you're welcome to email this email. I'll just go using here. Yeah, you're welcome to email this email if you have any more questions. And thank you again for coming and for your interest in iGEM and the team.